Hi, in this video, I will be teaching you how to perform test of significant difference for one sample data in RStudio. When we do such test, it is important to know which of the two tests, one sample t-test or one sample Wilcoxon-Test, should we use to analyze the data. The one sample test of significance determine whether the sample mean or median is statistically different from a known or hypothesized value. These are useful in the following situation. Suppose you are interested in determining whether an assembly line produces laptop computers that weigh 5 pounds, or you want to test if the average height of male Filipinos is 162 centimeters. Notice that each scenario, an assumed value is stated, which is your hypothesized value. Now, let's discuss the one sample t-test. This is a parametric statistical procedure used to examine the mean difference between the sample and the known value of the population mean. The R function for this test is given below. T.test function allows us to perform a t-test in RStudio. Object 1 contains the dataset that we want to analyze. The comparison value in the mu argument is your hypothesized value, and the alternative argument allows us to set which of the alternative hypotheses are we considering. This can be either greater, less, or two-sided. The assumptions of the test are the following. Your variable should be measured at the interval or ratio level. The data are independent, which means that there is no relationship between observations. There should be no significant outliers, and your dependent variable should be approximately normally distributed. For the first two assumptions, this can be easily controlled when you plan your research instrument and your data gathering procedure respectively. However, for the third assumption, box plot can be used to test if the data has significant outliers. This will be demonstrated later. Finally, for the fourth assumption, according to a technical paper published by Minitab, for as long as the sample size is greater than 20, this assumption is not that important. The one sample t-test is robust to violations of the normality assumption. To read more about this article, the link to the technical paper is provided in the description. If the data violates any of the assumptions, we use the one sample Wilcoxon-Test. This is a non-parametric alternative to a one sample t-test. The test determines whether the median of the sample is equal to some specified value. The R function for this test is given below. Wilcox.test function allows us to perform a Wilcoxon-test in RStudio. Object 1 contains the dataset that we want to analyze. The comparison value in the mu argument is your hypothesized value, and the alternative argument allows us to set which of the alternative hypotheses are we considering. These can be either greater, less, or two-sided. The following flowchart will help you decide which of the two tests will you use for a one sample test of significance. We first ask if the sample size is greater than 20. If the answer is no, then we use one sample Wilcoxon-Test. Otherwise, we identify if there is at least one outlier in our dataset. We may use the box plot to identify possible outliers. If there is no outlier, we use one sample t-test. Otherwise, we use one sample Wilcoxon-Test. The image shown is an example of a box plot. Notice that on the no allergic rhinitis box plot, you see a small circle. That circle may be considered as an outlier. Also, since you cannot see a circle on the allergic rhinitis box plot, it suggests that the data contains no outliers. So, if you see at least one circle on your box plot, possible outliers are present in your dataset. Hence, it is suggested that you use the non-parametric test. Now, let's perform a test of significance for a one-sample data. In this demonstration, we will be using the women dataset available in RStudio. To view the data, we type View, make sure that V is capitalized, open parentheses, women. Highlight the code and press Ctrl Enter. You can see that it has 15 data points and 2 variables, height in inches and weights in pounds. This dataset gives the heights and weights of American women aged 30 to 39. Suppose further that we test the claim that American women are taller than the average height of Filipino women at 0.05 significance level. According to a Google search, the average height of Filipino women is approximately 4 feet and 10.89 inches, or 58.89 inches. Since this is a one-sample test of significance, we decide which of the two tests, one-sample t-test or one-sample Wilcoxon-Test, will be used to analyze the data. We go back to the flowchart provided earlier. Since the sample size is less than 20, it is safe to say that the appropriate test is one-sample Wilcoxon-Test. Now, we formulate the null and alternative hypotheses for this test. The null hypothesis is that the median height of American women is equal to 58.89 inches, whereas the alternative hypothesis is the median height of American women is greater than 58.89 inches. We have this alternative hypothesis because the claim says that American women is taller than the average height of Filipino women, which is 58.89. To perform a one-sample Wilcoxon test in RStudio, we type Wilcox.test, open parentheses, women, $, height, comma, mu equals 58.89, comma, alternative, open quotation mark, greater. The Wilcox.test function allows us to perform a one-sample Wilcox test in RStudio. Women $height is where the data points are stored. The mu is equal to 58.89 is the argument that indicates the hypothesized value. And the alternative equals greater tells us that we have a one-sided alternative hypothesis, specifically the greater than. Highlight the code and press Ctrl Enter. In the console window, you will see the result. If you were not able to see this and you get some errors, check the spelling, capitalization, and the syntax of your code. This will solve most of the problem. The V, which is equal to 118, is the test statistic, whereas the p-value, which is equal to 9.155, e -0.05, is the probability that you will get your data, assuming that the null hypothesis is true. This means that the p-value is equal to 9.155 times 10 to the -5 power, which is smaller than our significance level. With that, we reject the null hypothesis and accept the alternative. Therefore, American women are significantly taller than Filipino women based on median results. To investigate further, we can compute the median height of the sample. We can do this by typing median open parentheses, women, $, height. Highlight the code and press Ctrl Enter. The median height is 65 inches. For our second demonstration, we will be using the bottles dataset, which can be downloaded in the description below. Once you're done downloading the file, upload it in RStudio by typing bottles, read.csv, file.choose, open parentheses, forward, comma, header equals true. Highlight the code and press Ctrl Enter. In this window, let's locate the file. In my case, it's here. Next, we view the data in the environment or history window. This dataset contains 29 observations in one variable, which is the volume in milliliters of every bottle a bottle filling machine produces. It is expected that the bottle filling machine must fill the bottles with soft drinks to a volume of 500 milliliters. However, an inspector believes the machine is not working properly, which means that it is either underfilling or overfilling the bottles. A sample of 29 bottles is taken and the volume of liquid inside is measured. Then, we test it using 0.05 level of significance. Now, we use the flowchart to identify which of the two tests will be used to analyze the data. Since the sample size is greater than 20, we must check if outliers are present in the dataset using boxplot. To generate boxplot in RStudio, we type boxplot, open parentheses, bottles, $, volume. Bottles is where the dataset is contained, whereas volume is the column name for the variable in the bottles dataset. Highlight the code and press Ctrl Enter. Notice that we cannot see any circle in the graph. With that, we may assume that there are no outliers in the dataset. Therefore, we will use the one sample t-test. Now we formulate the null and alternative hypothesis. The null hypothesis is that the average volume the bottle filling machine produces is 500 milliliters, whereas the alternative is the average volume the bottle filling machine produces is not equal to 500 milliliters, because the inspector believes the machine is either underfilling or overfilling the bottles. Or, in other words, the volume is not equal to 500 milliliters. Now, we perform a one-sample t-test in RStudio by typing t.test, open parentheses, bottles, $, volume, comma, mu equals 500, comma, alternative, open quotation mark, two-sided. The t-test function allows us to perform t-test in RStudio. Bottles $volume contains the dataset that we need to analyze. The mu is equal to 500 argument tells us that the hypothesized value is 500, whereas the alternative two-sided argument tells us that we are performing a two-sided test. We highlight the code and press Ctrl Enter. In the console window, you will see the result. If you were not able to see this and you get some errors, check the spelling, capitalization, and the syntax of your code. This will solve most of the problem. The t, which is equal to negative 0.50623, is the t-statistic. df, which is equal to 28, is the degrees of freedom, whereas the p-value, which is equal to 0.6167, is the probability that you will get your data assuming that your null hypothesis is true. Since the p-value is greater than our significance level, which is 0.05, we failed to reject the null hypothesis and conclude that we have no sufficient evidence to say that the bottle filling machine is underfilling or overfilling the bottles, making the claim of the inspector baseless based on empirical results. In addition, the mean of the sample is presented below, which is equal to 497.7921. Also, the 95% confidence interval is displayed. For our last demonstration, we will use the salary dataset, which can be downloaded in the description below. Once you're done downloading the file, upload it in RStudio by typing salary, read.csv, file.choose, forward, comma, header equals to true. Highlight the code and press Ctrl Enter. Next, we view the data in the environment or history window. This dataset contains 33 observations and one variable, which is the salary in peso of some randomly selected employees in a hypothetical company. Some allegations were made against the company that they underpay their employees. Suppose that the minimum salary of an employee is 14,000 pesos. We test the claim at 0.05 significance level using the dataset provided. To identify which test will we use for this analysis, we refer to our flowchart. Since the sample size is greater than 20, we now check the box plot. We type box plot, open parentheses, salary, $, salary. Highlight the code and press Ctrl Enter. Notice that we have 4 circles on the upper portion of our box plot. This suggests that there are outliers in our data. Hence, we will use the one-sample Wilcoxon-Test. Now we formulate the null and alternative hypothesis. The null hypothesis is the median salary of the company is equal to 14,000 pesos, whereas the alternative hypothesis is the median salary of the company is less than 14,000 pesos. The alternative hypothesis is formulated that way because the claim is that the company underpay their employees, which means that their median salary is less than 14,000 pesos. In the source window, we type Wilcox.test, open parentheses, salary, $, salary, comma, new equals 14,000, comma, alternative quotation, less. Highlight the code and press Ctrl Enter. On the console window, we will see the result. If you were not able to see this, and you get some errors, check the spelling, capitalization, and the syntax of your code. This will solve most of the problem. Based on the p-value, which is equal to 0.3232, we failed to reject the null hypothesis and say that there is no sufficient evidence to say that the company underpays their employees. This means that the claim is baseless based on empirical result. To investigate further, we can compute the median salary of the sample by typing median, open parentheses, salary, $, salary. Highlight the code and press Ctrl Enter. Therefore, the median salary is $13,981. In practice, there are other ways to identify which of the two tests should you use for your analysis. The procedure presented here is a good start for you to practice your data analysis skills. However, I do not suggest you performing initial analysis such as Shapiro-Wilk test to test if your data passes the assumption of a parametric test. To know more about the dangers of performing initial analysis, I attach several research papers for you to read. That ends our video, and I hope you learned something. Thank you very much for watching and have a great day.